All right, hey everybody. So now I'm going to talk about probability distributions. This particular one um, is a set of data that has just various probabilities. All right, so I think I have all this ready every time. Okay, a random variable is just something that's determined by chance. The number of heads you flip when you do a coin, the number of girl dogs if you have 3 dogs. So it's just like what you're looking for. Discrete means it can be counted. Continuous means it cannot be counted. So something that would be discrete would be like the number of pages in a math book in our stats book, versus continuous would be the wind speed of a hurricane, because like we saw with like Hurricane Harvey, it had the highest winds ever on record. So we could always have a worse hurricane. And so it's just kind of an infinite number. It's continuous. Okay, a discrete probability distribution means that for each thing that can occur, there's a specific discrete probability. Let's do one. So, oops. Here we go. E is the event that's happening, and then P of E is the probability of that event. So if we're doing a die, remember the thing goes 1, 2, 3, 4, 5, 6. And so the probability of rolling a 1 is a 1 out of 6. The probability of rolling a 2 is 1 out of 6. Probability of rolling a 3 is 1 out of 6. Probability of rolling a 4 is 1 out of 6. Probability of rolling a 5 is 1 out of 6. Probability of getting a 6 is 1 out of 6. And so that's a probability distribution. Right? Probability distribution, code for chart. Okay? And so we can take probability distributions and show it as a graph. And then from there, we determine the shape of the distribution. Remember, shape was, you can be normal, you can be left skewed, you can be right skewed. All right, so assume we toss 3 coins. We're going to use H for heads, T for tails. And so we can get all heads, we can get all tails, we can get 1 head with 2 tails, we can get 1 tail with 2 heads. And so that's our sample space. There are 8 choices that could occur. And so now let's do our probability distribution. The event and then the probability of the event. So the event would be having 0 heads, having 1 head, having 2 heads, having 3 heads. So it's out of 8. 0 heads would be all tails, and that happened once. Having 1 head, that's here, that happened 3 times. Having 2 heads, that's here, that happened 3 times. Having 3 heads, that's all heads, happened 1 time. So that would be that probability distribution. We wanted the graph. 8. The probability goes here. The event goes here, so it would be 0 heads, 1 head, 2 heads, 3 heads. And so 0 heads is 1/8. 1 head is 3/8. Pretend this is like a bar graph. 2 heads is 3/8. 3 heads is 1/8. So oops, kind of big. So big. All right, you get the point. Right, so it's just a bar graph. This is, if you look at the shape, The hump is in the middle, so it is normal. All right, for something to be a probability distribution, we're going to go back to those two main definitions, which is the sum of the probabilities has to equal 1 or 100%, and then each event has to be between 0 and 1. And so we're going to look at these four and see if those are if it could occur and if they're a probability distribution. So I'm going to look at all right. 0.2 plus 0.6 plus 0.1 plus 0.3. Whoa, whatever. Okay, hang on. I get 1.2, and that is greater than 1. So this is no, right? 1/4 plus 1/8 plus 3/8 plus 1/8 plus 1/8. 1, 1, 3. Right, I want to show you how I type that in my calculator. Okay, so for each fraction, I put it in parentheses, and then I put addition, and I get 1. So you can add the fractions by hand, you're welcome to, but we have a calculator, and we can use our resources. So we get 1, so that works for that guy. Then we need to figure out each one of those fractions. Is it between 0 and 1? It sure is. All right, then we have 1 plus 2 plus 3 plus 4. That does not equal 1, so it fails right there. And then 0.6 plus negative 0.5 plus 0.4 equals 1, but this negative 0.5 is not between 0 and 1. So it fails right there, so this is also a no. All right, so we've determined how to find the mean, that's the average, the variance, and the standard deviation for different samples and populations. So now, if you just have a probability distribution, I'm going to show you how to find the mean if it doesn't fall like within a set of numbers, if you have probabilities of events happening. So this is the formula. Okay, I'm going to show you what it means. So I don't want you, there's a couple of crazy formulas here, and I don't want you to get stressed out about them. Because I'm going to tell you what they are, like in normal people terms. I need to change this to 3. Don't want to do 5, it's huge. So first I need to do my sample set. So I could have all girls, I can have all boys, I can have one girl, 2 boys, I can have 1 boy with 2 girls. All right, so my probability distribution is, I can have 0 girls, 1 girls, 2 girls, or 3 girls. So for 0 girls, that's all boys. It happens 1 out of 8 times. Hopefully this looks familiar. For 1 girl, that's here, it happens 3 out of 8 times. For 2 girls, that's there, it happens 3 out of 8 times. For 3 girls, it's all girls, it happens 1 out of 8 times. So we need to find the mean. So what we're going to do is we're going to multiply this guy, add it, multiply that guy, add it, multiply that guy, add it, multiply that guy. So I'm going to do 0 times 1/8 plus 1 times 3/8 plus 2 times 3 plus 3 times 1/8. And that will tell me the mean. And I'm literally going to type it in my calculator exactly like that with the parentheses. Okay. Until I get 1.5. So our mean is 1.5. And remember, you can use the mu, this guy, or you can use X bar, but it's 1.5. All right, now let's learn about variance and standard deviation. Again, there's a crazy formula, but the thing I want you to notice is, all right, variance is still sigma squared. Standard deviation is still that sigma. All right, standard deviation is still the square root of variance. So what we're going to do is we're going to find variance, and then we will take the square root for standard deviation. For variance, we're going to do some calculations, and then we need to subtract whatever we get for the mean. All right, so we did this, I don't know. All right, so number of spots. You have 1 spot, 2 spot, 3 spot, 4 spot, 5 spot, 6 spots on dice. And so that probability is all 1/6. All right, so first I want to find the mean. So the mean is going to be 1 times 1/6 plus 2 times 1/6, 3, 3 times 1/6 plus 4 times 1/6 times 1/6 plus times 1/6. And I'm literally going to type it in my calculator like that. I don't have a 0 here because there's not an event where there's no dots on the side of the dice unless like there's a magician and all of a sudden he makes everything disappear. Alright, I get 3.5. And you probably would think it's 3. It's 3.5. Alright, so this variance looks exactly very similar to this formula. I'm going to go ahead and write it down. Alright, and I want variance. Let's look at something real quick. For variance, the difference is I'm going to square these guys. So it's going to be 1 squared times 1/6 plus 2 squared times 1/6 plus 3 squared times 1/6 plus 4 squared times 1/6 plus 5 squared times 1/6 plus 6 squared times 1/6. Then we're going to subtract whatever we got the mean squared. So I'm going to type, so notice it's like the exact same. Except I'm going to square those numbers. So I'm typing it in right now. So I get 15.2 minus 3.5 squared. And I get 2.9. All right, that's variance. Okay, and if I want standard deviation, I just, so standard deviation is going to be the square root of 2.9. So square root 0.9, I get 1.7. And then my mean was that 3.5. All right, I'm going to do a couple more problems in the next video.